Alright, this is a video on mole relationships or a mole ratio. This is page 8 of your summer homework packet, and it's question number 1. So if you look at this balanced equation, we have 2 molecules of H2S react with 3 molecules of O2 to form 2 molecules of SO2 and 2 molecules of H2O. And so everything that when this reaction happens, everything has to occur in these ratios. And so, for instance, if I double everything, let's say I have this here times 2, and I make this 4 molecules, well then I would need twice as many of these to react. I would form twice as many of these, and I would also form twice as many of these. And so, so everything is in the same ratios. Or if I were to have, let's say I had a dozen of each thing. So now I have a dozen sets of these, or a dozen sets of these, a dozen set of these, a dozen set of these. Everything's always in the same proportions. And so what chemists do is we scale everything up to moles now. And so instead of multiplying it by only 12, let's say I multiply it by, so now I have it times 1 mole. Okay, I do the same thing here. And you can see that now I would have 2 moles of these. I have 2 moles of these, 3 moles of these, and 2 moles of these. So if you take 2, 3, 2, 2 and multiply it by 6.02 times 10 to the 23rd, you're essentially getting 2 moles, 3 moles, 2 moles, and 2 moles of everything. And so this allows us to figure out how many of each thing you can make if you're given a certain amount of something else. So, so in the Calm homework set, there are some questions that say, for instance, what if I had 0.2 moles of H2S? So let's say if I start with 0.2 moles of H2S, then how much of everything else would I need because of that? Well, this is a relationship where just looking at the numbers of the coefficients, 0.2 is related to by just taking 2 divided by 10. And so everything else would be scaled up in the same way. I would have 0.3 moles of this. 2 and 2 is the same number, so I'd have 0.2 moles of this. And I would have 0.2 moles of H2O. Okay, so everything is scaled up in the same way. And these numbers are pretty easy to work with, and they're easier to see. Now, a lot of times the numbers that we get are a little trickier, and they're harder to determine certain amounts. And so let's just take a look at the first question here. First question asks, if I'm given 8 moles of hydrogen sulfide, how many moles of O2 would I need to perform this reaction? And so to do this problem, we're introducing something called the mole ratio. And the mole ratio, what that tells is if I'm given this balanced equation here, the balanced equation tells me that for every 2 moles of H2S, you're going to need 3 moles of O2. Okay, so this is what I call the mole ratio for the two things that I have. And so when I want to figure out, if I'm given 8 moles of H2S, I'm trying to figure out how many moles of O2 I need to do this problem. Instead of trying to figure out things in my head, I can set up a ratio. And so this is my given right here. I'll start with a given over 1, 8 moles of H2S. And then instead of, like I said, trying to figure out in my head, I'm going to use this relationship between H2S and O2. And it says for every 2 moles of H2S, so I'm going to put 2 moles of H2S on the bottom, I'm going to put 3 moles of O2 on top. And so now what I'm doing is using factor label method or dimensional analysis, I can cancel out my moles of H2S. 8 times 3 is 24. 1 times 2 is 2. And I can see that's 12 moles of O2. And so what this tells me is for every 8 moles of H2S, I need 12 moles of O2 to react with it. And so if you look at question number 2 of the problem set, question 2 has nitrogen. So this is the formation of ammonia from nitrogen and hydrogen. And it asks how many moles of ammonia can be made. So my given is 0.15 moles of nitrogen, N2. And I have a question mark, moles of NH3 that I want to make. And so once again, look at your balanced equation. My mole relationship between N2 and NH3 is for every 1 mole of N2, I'm going to make 2 moles of NH3. So a mole ratio is 1 mole of N2 gives me 2 moles of NH3. And so if I want to solve this problem, I can take 0.15 moles of N2, my given over 1. Now my relationship's a 1 to 2 ratio, so I can say for 1 mole of N2, that gives me 2 moles of NH3. Multiply straight across, 0.3 divided by 1 is 0.3 moles of NH3. So now instead of trying to figure things out in my head, I have a ratio I can use to solve how many moles of something I want to have or I need given another mole of something else.